Alright, so in this video we're still reviewing a little bit about functions in general. In this particular video we're talking about x and y intercepts of functions in general. Now, in the example we're just going to use a linear function, but the idea to find the x-intercepts and to find the y-intercepts will apply to any function. So just keep that in mind. This works for any function. We're just going to use a linear function for our example because that's pretty easy. So the x-intercept of any function is the point or points, could be more than one, where the graph of the function crosses the x-axis. Likewise, for the y-intercept of any function, there could be more than one, and it's where the graph crosses the y-axis. So we want to know what the x and y-intercepts are of the function y equals -1/2 x plus 4. There's a typo here. This should be a -1/2 x plus 4. So go ahead and fix that in your notes if you haven't already. All right, so now what I want to do is to first find the x-intercepts. Well, for x-intercepts, it's the point where the graph crosses the x-axis. So I'm just going to kind of draw a sketch. And -1/2 x plus 4 is going to look roughly, again, this is just a sketch, roughly something like this. So I have my x-intercept is where it crosses the x-axis. My y-intercept is where it crosses the y-axis. Well, for x-intercepts, you might notice that the graph at here, y equals 0. So I have x, comma, 0. So x tells me how far right or left I need to go. It's 0 because it's crossing the x-axis. And we know that the x-axis, y is 0. So what I'm going to do is literally plug in 0 into my function. So I get 0 equals -1/2 x plus 4. And what I'm going to do now is solve for x, because that's going to tell me how far right or left I should go with my graph to find this x-intercept. So my first step here is to just subtract 4. Cancel out. So -4 equals -1/2 x. And now I want to get rid of this fraction, so I'm going to multiply by -2 on both sides. What you do on one side, you have to do to the other here. -1/2 and -2 cancel out. So I'm just left with -2 times -4, which is +8 equals x. Okay, so my x-intercept is 8. Now, you could write it this way, but most of the time, an x-intercept is a point on the graph, so it's going to be 8, 0. All right, so just keep that in mind. Now, it's kind of a similar idea for y-intercepts. But this time, what we're doing is on the graph, we're crossing the y-axis. So we know when we touch the y-axis, x is equal to 0. All we need to do is figure out what y is, because that's going to tell us how far up our y-intercept is or how far down our y-intercept is. So again, I'm going to my function, y equals -1/2 x plus 4, and everywhere I see an x this time, I'm going to put in a 0. So what the point is going to look like is 0, y. Here, y is just any number. All right, so I have y equals -1/2 times 0 plus 4. Well, just clean this up. -1/2 times 0, that's just 0, so I'm just left with y equals 4. That's my y-intercept. But again, typically what we're going to see is we're going to see that written as a point, so it's going to be 0, 4. Okay? And that's how you find x and y-intercepts. Again, to find the x-intercept, essentially what you're doing is plugging in 0 for y and solving for x. To find the y-intercept, you're plugging in 0 for x and solving for y. And this works for any function. Also, there could be more than one x-intercept or more than one y-intercept, depending on what type of function you have. And we'll see that later on in this chapter. But that's it for this video. Let me know if you got questions.